Down your side of the room.
No. It's in 2 weeks.
What?
Oh, yeah.
All right, so yesterday we talked about work, right? And we said work was what? What we say? Force acting through a distance. Now, we said that there were some common verbs that we could use to describe work. What were those common verbs? Because we're going to look at some pictures in a few minutes to try to figure out if work is done or not done. So what kind of things can we use to describe? Push, pull, throw. If you do those things, generally speaking, you're probably doing work. One word said most likely is not doing work is what? Carrying. Now there's some exceptions to that, but a lot of times when you're carrying something, you're not doing work. So we wrote down, I hope for most of us, we wrote down the 2 requirements to do work, because this is what's going to be important when we look at the pictures in a few minutes. All right? You have to do what? All right, you have to move a distance. So for those of you who didn't write it down, write it down. It's important. Okay? You must move a force over a distance. And if memory serves, the example I gave you was if I put Jacob up here pushing on this wall, the entire time y'all go to lunch, and he drips a puddle of sweat on the floor, did he do any work?
No.
No. He didn't do any work because did the wall move?
No.
No. You have to move a distance. If y'all take weight training.
Yeah.
If I have you do lifting weights, and all you do is hold the weight over your head, are you doing any work?
No.
If you're holding the weight over your head? No. You're just holding it. You actually have to do what with the weight?
Move it.
Move it. If you lift it up or you lower it down, you're doing work because you're moving the weight a distance. But if all you're doing is holding it over your head, even though that's really hard and you're getting really tired and your muscles are hurting and burning, are you doing any work?
No.
No. You have to move it that distance to do work. Now, the second thing is the force and the distance must be in the same direction. And I told you to think about this as being what? Parallel. Because sometimes people have an easier time with being parallel than same. All right, because it doesn't necessarily have to go the same direction as long as they're parallel directions. Okay, and that can be just as important. Now, we're going to look at a couple examples to illustrate, for example, why carrying is not defined as work. Now, does everybody have that from yesterday? Everybody good? Okay, so examples of work being done. We're going to let's do the stairs because we're going to talk about stairs tomorrow. The forecast, what's the forecast calling for? I hope it's not going to rain tomorrow.
It doesn't rain all week.
Yeah, let's hope not.
Let's hope we have sunshine.
They calling for tomorrow.
Rain.
Tomorrow, right now, 50% chance.
75% rain.
Let's go right now. Let's do it today. It's not raining.
Let's do it today.
Yeah, I'm raining right now.
It says scattered thunderstorms. They're not usually having a thunderstorm during about third period. We'll hope for the best. We're only going to be outside about 20 minutes. So we're going to do it right now. So like I said, I can't do it right now. You don't have to do any calculations. All right, so.
We get 15 cents out there.
And let's do it after we get calculated.
So, if we have time later, we'll see. All right, odds are good we won't have time. All right, so if we climb the stairs, okay, First of all, what direction are we going when we climb stairs? Okay. So our distance that we're going to go is up. Okay. What direction is our force going to be?
Down.
Okay. A lot of people say down, and that's perfectly okay. All right. It doesn't matter. That's why I tell people all the time when we talk about this. That's why I use the word parallel all the time. Okay. Because a lot of people go, when we talk about this, for their force, why did you say your force was down?
Because they're pushing down to go up.
Okay, some people say they're pushing down to go up. What other force might you have argued?
Up.
All right, think about your down force. What force is pulling you down?
Gravity.
A lot of people say gravity's pulling you down, okay? A lot of people say gravity's pulling you down, okay? Particularly us fat people. A lot of gravity pulling us down. Huffing and puffing by the time y'all get to the top of the stairs. All right? Now, some people will say your force is up. Why is your force up? Because you got to do what? You got to push yourself up. You got to use some force to go up the stairs. Any of y'all levitated yourself up the stairs? Yeah, I wish too. It would have helped me a whole lot before I lost 20 pounds. Last year, if I'd have walked upstairs, whew, I was huffing and puffing by the time I got there. I huff and puff a little less now. Okay? So, now we have to use some effort to climb the stairs. Every one of us, and y'all got classes upstairs? You all got to use some effort to go up the stairs. I mean, you don't float up the stairs. You got to use some muscle and a little bit of effort to lift your feet to climb the stairs. Okay? Those of us who are a little fluffy like Miss Wall, got to use a little more effort. Okay? Those of us who are Ashante might have to use a little less effort. Got a little more, less to carry upstairs. Okay? But my point being, whether you think of it as gravity is holding us down or our effort to lift ourselves up, either way, when you consider we're going up and this is our force, what can you tell me about them? Are they parallel? Yes. So, your force and your distance are parallel. So, are we doing work? Yes. Okay, so when we climb stairs, work is done. Which is why going out to the stadium and climbing stairs is a great example and an easy one for us to do to calculate our work. And in a few minutes, when we talk about power, for us to calculate our power climbing stairs tomorrow. Now, is an example of work not being done. All right? We talked about this yesterday. Let's say you guys go to cafeteria. Okay? I can't draw a book bag. So you got some books in your hand. Okay? Now, y'all are off to the cafeteria. So your distance is this way, right? Y'all are carrying book bags, books and things, right? Now, whether, again, you consider the force that's pulling on the books. What's pulling on the books? All right, if you say you, okay, again, you're providing some effort to hold the books up. Or I heard somebody say, what's pulling the books down? Gravity. Whichever one you consider, it doesn't matter which one. Whether it's you holding the books up or gravity pulling the books down. What can you tell me about this direction and this direction? They're not parallel. Okay? They are not parallel here. So there is no work. Now, this example is just like carrying a baby or a younger brother and sister or a cousin. We talked about this yesterday. I asked how many of you had younger siblings, younger cousins, brothers, friends who have small children. You have to tote them around. They get heavy after a few minutes, don't they?
No.
After about 10 minutes of carrying them, you're like, dang, kid, you're heavy. I'm putting you down. All right? Are you doing any work when you're carrying them around, walking around?
Yeah.
No. The effort to hold him up, gravity to pull him down, that force is in this direction. If I'm walking this way, my direction is this way. So I'm going this way, the force is this way. Are they parallel? No. Okay? So even though it's tiring, your arm hurts, your hip hurts, you want to put the kid down, are we doing any work according to the science definition? The answer is no. Okay? Yes.
Same holding a book or something.
If you were holding a book doing what?
Jumping on a trampoline. That considered work?
Because you're going up and down with the distance, then yes. That's why I said you can't always say it's not work to be carrying or holding something. If you were carrying the kid going up and down the stairs, then your distance is up and down, and the force is up and down, so that would be considered work. Jumping on the trampoline would be considered work, because they're going to be parallel again. But just walking, no. So if you were carrying groceries, would carrying groceries be considered work? No, because again, you're going this way, and the force is this way. Okay? Does that make sense? If you were lifting groceries off the floor and put them on the counter, would that be work?
Yeah.
Yes.
You gotta lift them up.
Because you got to lift it. Okay? That's considered work, because you're going up with them, and the effort or the force is up. The distance is up. Okay? Lifting is work. Carrying is not work most of the time. Okay? Now, how are we going to calculate work? Find your formula sheet. Find your formula sheet. This is your orange card. Don't make green cards anymore. Those are just leftovers.
F like round.
Huh? Yeah, I don't make them anymore for that reason. I got tired of people picking on them. It never occurred to me.
Never occurred D when you made a group like that.
I just like the color. All right. W equals what?
F like weird triangle.
All right. Does everybody see it? W equals weird triangle D according to William back there.
Isn't that a
Yes, it's change in distance. Now, do we have to have the triangle there?
No.
What's the triangle mean?
change?
Okay, but for all practical purposes, that means if two distances, we do what? We subtract. What if there's only one distance? We just use it, okay? So it's the same thing as W equals F times D. Because if there's only one distance, we just put in the one distance. But if there's two distances, then we subtract it. Okay? Because are you always going to have two distances? No. Sometimes you will. A lot of times you won't. You'll just have one. Does that make sense to everybody? Okay. Say what? I have no idea. Now, the units for work. All right? If we plug in a force unit, what's a force unit? Newton. What's the distance unit? Anybody know or remember? Kilogram is mass. What's one of the other ones you said?
Meter.
Meter is the right answer. All right, Newton meter. Now, Newton meter is an odd unit, and we've come up with a new name for Newton meter, okay? Newton meter is called a joule, okay? It looks a little bit like joule, but we don't pronounce it joule. This is actually a famous scientist's last name. I'd have to look up his first name. I've forgotten over time. I want to say Isaac, but I know that's wrong. All right, joule, all right? Joule has a symbol, and we abbreviate it as what? J. So work is going to have a J. How we're going to abbreviate it. What is that man's first name? That's going to irritate me that I don't remember. John. Could be, but it doesn't sound right. What? Jewel. Right, apparently there is a rain boot. Wikipedia will probably get to it faster. Yeah. English physicist James Prescott Joule. The object was wrong.
JJ.
All right. Everybody caught up with me? All right, let's calculate. Now, for a lot of you, this stuff is pretty easy. So for those of you who are doing great with the math, I don't want to hear from y'all. Okay? So William and Logan, don't call. Okay? Don't answer. Okay? This is directed at those people who are having a harder time with the test at this point. Okay? Because y'all are not. With the math portion, at least, anyways. Because we're going to practice the math after we cruise through power. So we're going to predominantly spend most of class on after we do the notes. Because tomorrow, if you can't calculate, is there any point in doing the lab?
No.
Because every single person is getting their own times on everything. So everybody has to be able to do their what? Their own calculations. If you can't do that, we're wasting our entire day tomorrow. All right. So if we want to find work, how do we calculate work? What's the formula for work? F times distance. All right. Now, when I look at this, Alexis, what are we asked to find? Okay. So we're looking for W. All right. So if that's what I'm asked to find, Damien, give me something I know out of that question. All right, so that Newton's is going to go where? The force or the distance? Okay. So that means my 8.5 meters has to be the what, Sierra? Has to be the what? The distance. So when I go to punch that in my calculator, what am I going to do with those two things, Caleb? How am I going to calculate that? When you look at that, nothing rings a bell for how to calculate that? If you see that? If W is by itself, what does this mean in math class? So what are we going to do with that 200 and that 8.5? So you're going to take the 200 and multiply it by 8.5. Okay, so say 200 times 8.5, and that'll give you your answer. 1,000 and 1,700. Okay, now what unit are we going to put on the answer? We're going to put a J there. Okay, now, does that make sense? All right, if we try another one. Now, if you have 500 joules of work lifting a 20 Newton, that's his box of books, how far did you lift the box? You do 500 joules of work lifting a 20 Newton box of books. How far did you lift the box? I don't hear from you either. All right, so what are they asking me to find here, Mr. East? What do you think? Or give me something you know. I'll even open it up wider than that. Tell me something you know up there.
How far?
Okay, so it's how far, the work, the force, or the distance? Not quite. How far? It's the distance. Good. Okay. So, tell me this, Carla. Carla, you awake? Okay. Is the 500 joules or the 20 newtons something you know up there? Tell me something we know. Can you put one of those two numbers in the right place? I'll take either one. Which one do you think you know? Yep. Which one? You can either tell me which one's work or which one's force.
Can I tell you
Sure, which one's the 20 one?
force?
Sure. So I'm going to put the 20 newtons where the force is. So that means the 500 is the what?
The work.
Yeah. All right. So now that I know that, how am I going to solve? What am I going to do to solve, Bree?
You divide it.
That's right. How'd you know that? How'd you know?
What do you mean, how do I know?
How do you know? Because some people don't know.
Because, like, you can't do the work because you don't have the force and distance. And you're supposed to do opposite of multiplication.
That's exactly what I want you to say. All right. This means what?
Multiply.
So the opposite of multiply is what? Division. So you divide by 20 on both sides because it's the opposite of multiply. So you divide by 20. And what's this?
25.
25. And what's the unit for a distance? Meters. Okay? All right. Let's talk power. Because I won't have time to calculate today. That's where some of us need our most practice, is the calculators. We have got to be able to calculate. And it's very possible we could get to starting the lab today if we do well with the calculator. All right, what is power? Anybody know? Any ideas?
I have no idea. Increase.
All right, it's the rate at which work is done. Now, I used a word here that a lot of people use, but they don't often know what it means. What does it mean to say rate? Sort of. Okay. All right, the rate at which work is done essentially means how fast work is done. So tomorrow, or today, depending, if we get started on the lab and we go out to the stadium stairs to climb the steps, when we measure our power, some of you will be more powerful than others. Why? Based on just that definition. Why would some of you be more powerful than others just based on that definition? Some of you are going to be faster. So those of you who are slugs, who climb the stairs, what do you know about your power?
Don't have that much power.
You're not going to have much power.
That's right.
Now, those of you who race up the stairs, you're going to have what? You're going to have more power. Okay? Machines that are powerful generally do it what? Faster. That's why we use machines. Okay? Would we use a machine that did it slower and made it harder for us? No. Okay? That's one of the things we're going to talk about on Monday with simple machines. Would any of us opt to use a tool or a machine that made it more difficult for us to do a task? No. What would be the point of that? I can't think of any of us who would do that. I mean, I know some people who are stupid, but
No.
really. Nobody I know is that dim-witted. So, you behave over there. So how are power, speed, velocity, and acceleration related? Anybody tell me? Before I help you with it. Nope, they don't all have.
Speed doesn't have it.
That's right. I like what Bree said there. All right, y'all got that. But what did the first thing that Logan said is they all had direction, and Bree said speed didn't have direction, which was fabulous. I don't often get people who say that fast. All right. The second thing y'all all said is they all had what? Nope. They all say how fast something's going, so they all have what? I thought you said it a second ago. They all have time. So look at your formulas. Speed, what's the formula?
P equals speed.
What goes on top? Distance over time. Velocity is what? Acceleration is what? And what is, is that all I had? Power. That's the one we're getting ready to talk about. Power we're going to look up is work over time. So what can you tell me about all of these formulas?
They all got T.
They're all rates, which I think it was Logan who said that, which basically means they all have time. May have been William, I don't know. Somebody said it. Okay? They're all rates. They all have time. All how fast. So, tomorrow, possibly today, when we're climbing the stairs, if you want your power to be greater, you don't want your time climbing the stairs to be 13 seconds. Okay? Because your power will be ridiculously small. I mean, first of all, we're not going to have much power anyways. But it's going to be ridiculously small if it takes you 13 seconds to climb 22 stairs. Now, I didn't say race up the stairs and trip and break your leg either.
Yeah, William.
Something tells me you three are going to be problematic out there on the stadium stairs.
No.
I don't feel like falling and tripping down the stairs.
Well, that would be good. I don't want you to trip and fall down the stairs. Now, the formula for power. What's the formula for power?
Work over time.
Okay, so it says what on the sheet? Power equals change in. Okay, it says W equals the change in time. So again, do you need the little triangle?
Yeah.
No. Okay? You can just write P equals W over T. Because again, like I've said multiple times, this is if there are two times. Then you know that you will subtract. But if there aren't two times, you just plug in the one time into the time in the denominator. Sometimes there will be two times. Sometimes there won't be two times. It just sort of depends. Now, the unit for power. Some of y'all may know this one. Think about your parents and the utility bill. Anybody know the power unit? Anybody pay their own utility bill? Oh, that's at least something. Sometimes I get supposed to do.
I paid it, but I never paid attention.
Anybody knows?
Yeah.
Anybody ever been outside to look at the machine to see what it says?
Watch.
It's watts. Okay, the unit for power is watts. Now, this is where sometimes people get confused. Because what is the abbreviation for watts? What do you think? Yeah, I know, but we need to abbreviate it because we're not going to write watts on the end of every answer. It's W. Okay? So the abbreviation is a W. So when we write W, what do you think people think I just abbreviated?
Work.
Yes. Okay, and it's not. The W stands for watts.
I'll put WT.
Okay, that's not the abbreviation. Now, some power questions are very easy like this one. All right, this is as easy as it gets because it says how much power do you have if you have 50 joules in 5 seconds.
10.
So again, what are they asking us to find, Daniel?
Power.
What do they want us to find?
What?
Okay, or you can just tell me the word of the question. It wants to find the what? What is the power? So we know we're going to want to find power using this equation. And Damien said we're solving for power. So we need work and time out of the question. So what's my work, Janiyah? Okay, we're going to put 50 on top. What's my time, Caleb? Okay, so we're going to put it on the bottom. And how do I solve Mr. Hernandez? Divide. So 50 divided 5 is 10. Now, what unit do I put on a power, Alexis? What unit do we put on a power? What we just say? Power got a what? So we write W on the end of it to make it 10 watts. Everybody with me? Okay. Now, some of the questions aren't as easy, and I'll give you a moment to write that because this is going to be more like what we're getting ready to do. Okay? This is more like what we're getting ready to do. We're going to jumble these up a little bit. For some of you, it will still not be hard. For some of us, it will be. All right. Tell me this. What are they asking us to find? Okay. So we're looking for force. So what formula has force in it? Work equals times distance. Okay. So that's what we need, right? Do I have a distance? Because we're looking for F. Okay, my distance is what? 30 meters. Okay. This is why I've been pushing units on y'all all semester. This is where it's important. You need to recognize meters as a distance. Those of you who still can't do that, this is one reason you're struggling. Okay, 30 meters is a distance. Now, what did we just say the unit for work was today? Joules. Do you see a J anywhere up there in that problem? Huh, we can't find force. We don't have work.
You have to do the other formula and figure out.
That's right. You're going to have to stop for a minute. Let that sit off to the side. Take your other formula. Power equals work over time. And we got to find work because we don't have it. So, we need work because we don't have it. What's our power? What's our power over here? Okay, this is our power. Whoops, not B, dummy. So there's our power. So 500. All right, what's our time? 10. So I'm going to put 10 there.
50.
Okay? Now, this is where some of us are struggling. We can't figure out how to get the W. What is this right here? What does that mean? It means division. What's the opposite of divide? So we're going to cross multiply because that was divide. So W equals what? 5,000. Because a lot of you would have looked at that and said what? You would have divided and said 50 or whatever you got when you divided. Okay? But the opposite of divide is multiply. That's how you decide to cross multiply there. So you get 5,000. So this 5,000 goes right here. And now you have what you need to solve for force. So what do I do? All right, this means what? Multiply was the opposite of multiply. That's how I know to divide by 30. That's how I know to divide by 30. Force equals what? 166.6. What's the unit on a force? Newtons. That's your answer. Questions about how I did that?
I done it a different way. I divided 30 by 10. Answer that. I divided
30 by 10 will not work.
I divided 30 divided by 10, I got 3, and then I divided 500 by 3, and I got 166.
You just got lucky.
I don't even know what.
No, you just got lucky. That is not how you solve the question. You just got lucky. Because 30 divided by 10 would mean you took the distance and divided by time, which would be velocity. All right, questions? All right. We'll have there. Oh, we need to do that. We need to do this one real quick. I forgot about this one. You will see this one, not in what we're getting ready to do, but you will see it. Let's see what you remember. How much work is done when you have a 5 kilogram rock and it's thrown 10 meters? On the worksheet that we'll do sometime tomorrow, I put a hint in this one. I didn't put a hint on the one on the board though. What stands out to you? Okay, it says kilograms. What am I asking you to find? I'm asking you to find work. All right, what's the formula for work?
Oh, I
Over distance.
Okay, work equals force times distance. The distance is 10 meters. I hear that. Okay.
Find your force, you're gonna have to multiply 5 kilograms times 9.
All right, so did I give you a force?
No.
That's the problem. Most people don't realize that. They just slap the 5 in for the force. Okay? This is not a force. It's a mass. So you have to use F equals MA and find it. So force equals 5 times, what's your acceleration if they don't give you one? 9.8.
Which equals 49.
So you get 49, and then that 49 goes there.
Equals 490.
Yes. A lot of people get that wrong every semester because they look at that 5 kilograms and they just assume that's a force, and it's not. It's got to be a Newton. All right. Now we're at what we're getting ready to do. We're going to do 2 things. Here, Jacob. Come hand these out to everybody. All right, the first thing we're going to do is Jacob's going to give out the one with the pictures. All right, there are 8 pictures. We have to decide if the picture, first of all, is doing work. If the answer is yes, it's doing work, then we're going to calculate the work. If you decide, no, it's not doing any work, then you just write no work. Don't forget William. Okay? So, once he gets everybody a paper. Do it first as we go. Okay. So, in the first one, you got a bulldozer like they're using out there on the bridge scrap. Lifting a boulder. Straight up. Alright?
Yes.
What direction is the force?
Up.
Up. What direction is he lifting the boulder? So is the force and the direction the same? So, is work done?
Yeah.
Yes. So calculate work there. How do you calculate work in number 1 if you answered yes? Okay, you say force times distance. So you would say, force times distance, and you would have, what's that, 20,000 times 25, and you would calculate after you answered yes. Okay? So you're looking at the remaining 7 and figuring out yes or no, and then calculating. Everybody got it? All right. Did anybody else bring me late homework from yesterday? Besides the 2 that people brought me at the start of class? Yes. What direction is the force? Right?
Yeah.
And then what direction is the car going?
Straight.
So yes. Are we done? Where are we at? Nope, we're over. All right, what did we come up with number one? Let me get my
Point of interruption, Ms. Wall.
numbers. Yes. Yes,
Do you have John East?
I do.
John East?
Yes, I do.
Oh, okay, sorry.
That's
Could you send
okay.
him to the main office to sign out, please?
I will.
Thank you.
Welcome. All right, Mr. East, grab your phone off my desk. I'm going to give you what we're going to work on so you can maybe complete it for homework. Or contemplate doing it for homework. Put it here with your phone. And then you owe me detention tomorrow. All right, let me find my picture so I got my numbers. There we go. So we did the first one, we got 500,000, right? What unit did you put on it? All right, so number two was the ballerina leaping through the air doing work. Really?
Oh, yeah, I think she was lifting her leg up.
She's going up. What direction? Y'all jumped in the air before. What direction do you have to go?
That way.
She's going up.
Yeah, jumping that way.
I know, but she got to jump up before she.
She's got to jump up.
She got to jump.
She's got to jump up.
She's going in the
She's
air.
jumping up. All right, she's doing work. All right, 360. Okay. Now, hopefully, none of you ever have to mow grass this way in your life, because that's difficult.
I have.
With that kind of mower?
Yeah.
Really?
Yeah,
Mhm.
my grandpa.
It's actually easy.
Okay. Number three. Where are we doing work at number three? Yes or no?
Logan just too.
No.
Y'all stop that silliness. All right, are we doing work at number three?
Yes,
Oh, wait, number three.
yes,
Yes, you're doing work. So 2,400 joules. All right, number four.
No, because
No, she's just carrying the baby, so that's no work. Number five.
Yes.
Yes, 87,500 joules. Number six.
Yes.
Yes. Have y'all ever done that on the road?
Yes.
Used to be part of standard PE back when I was in
It
school.
looked like a pole.
That's what you gotta do it for, Justin.
4,200 joules. Number seven. Yes or no?
Yes.
Yes. What do you do with that 40 and that 65? You add them together. So 735 joules, and I hope none of you ever have this experience with cars. Is it working?
Yes, because they push up.
Yes, they're pushing it and they're going forward. So 1,000 or 120,000 joules. Questions about any of those? All right, let's talk about what we're getting ready to do. All right, for most of us, this is going to be harder because it's not a straight multiply and figure out if work is done or not. All right, so in this one, I'm going to give you a chart, and you're going to have variables like this, and you're going to have to figure out the missing pieces. Okay? So if you have something like this, and you say, okay, I'm going to find force. Well, if you try to find force first, force would use this formula. All right, well, I've got distance is 10. I want force. I need what?
Wait, Cody.
Not weight. What's W stand for?
Watts.
It's not watts. What's W? Work. Do I have work?
No.
So I can't use that formula first. So I would need to use this formula first and say, okay, do I have power? Yes, power is 250. I don't know work. What's time? 5. All right, what's this mean? So what do I do? So 250 times 5 is what? 1250? So 1250 is equal to my W. So W is 1250 joules. So now I can put that 1250 here and solve for my force. So now I'm going to do what to find force? Divide by 10. Divide by 10. The force is going to be 125 newtons. Okay, that's what we're getting ready to do. Okay, for those of us who have good math skills, it is. But for those of us who are in the struggling category, don't stand this now. Come here. I need to come here. I don't care.
Split it up. Make it 1/2. You get that.
Now, we're not necessarily going to do the whole sheet. I'm going to do row 1 with you. Now, I'm going to pick a different way. Turn my bulb on up here. Set it on this chair, we'll be fine. Yeah. Y'all stop.
Yeah, we're.
Sit down.
We'll catch you after you finish this.
I'll be there.
Don't stop that silliness.
I just smell your breath from over here.
Yeah.
All right. Let's say that we do row 2. Okay? Now, let me grab a couple sheets of paper to make this a little easier. I don't need the bell schedule anymore because we get out. What time did I tell you? 1:40.
You sure ain't.
All right. So if I cover this up, everybody can see how it works. All right. First of all, that's question 1 and 2. Okay, I'm not going to work this one, but basically you would have a force of 15, distance is 2, time is 3. You're solving for work. You're solving for power. That's the question you're working. Okay? Does everybody get it? Now, I'm going to do the second row. So the second row, I know what? This column is force. So my force is 50. My distance is, I don't know. My time is, I don't know. My work is 800. And my power is 32. Okay, that's what I know in the second row. All right, so what do I want to start with first? Distance. Okay, what formula had distance in it? What? Okay, Bree said the work formula. See if you agree with her, Alexis. You just going to agree? You sure? She might be wrong. You better check behind her. She could be wrong. Look up the work formula. See if she's right. What's the work formula say?
It's the 6th one. It's the 6th. 6.
I don't know if I'm right.
What does it say?
Whatever that is.
It means triangle D, but you can triangle out. So work equals force times distance. Okay, so do I know the work?
Yeah.
What is it?
Mhm.
So we're going to put 800. Do I know the force?
No. Oh, yes, 50.
Yes.
So we're going to put 50 times. You said we're looking for what? Okay, so what's the times? Tell us we got to do to solve. It's the opposite of times. So we're going to divide here. We're going to divide here. What are we going to divide by? We're going to divide here by 50. We're going to divide here by 50. That cancels. That's going to be distance equals, what did Jacob say? 16. So the unit's going to be 16 meters, and the units are at the top of the page. All right, so now we need time. What formula has time in it, Sarah? What formula we learned today has time in it? Huh? What formula did we learn today that has time in it? There's only two.
Power.
Yeah. What's the power formula say?
Power equals work over T.
Okay. So what number do we have for power? Board. It's on the board.
32.
What number do we have for work? Okay. What's this mean right here, John? So what's the opposite of divide? We're going to multiply. 32T equals 800. What's it mean when these two things are together? So what's the opposite of multiply?
Fine.
So we're going to divide by. Somebody tell me what I get.
25.
Questions? Everybody see how we did that? All right. I did the second row. So we know that we have 16 for distance and 25. Everybody has to do 5 rows. Okay? So 1, 2, 3, 4, 5. Okay? That's the end of second lunch. All right, everybody's got to do those 5 rows that I put a check mark beside. And I will be glad to help you if you get stuck or do not know what you're doing. So don't sit there and be on almost up. I'm going to stop this and post it.